All right, we're going to get right into it. This is the second half of 8.2, where we're going to We're going to focus on the factoring portion of our EQ and our topic. So our EQ for this video is what is the greatest common factor, often GCF. You've probably heard of it before. What is the greatest common factor, and how can I use it to factor polynomials? Okay, so just a quick little warm up. We're going to go ahead and do some distribution from the previous video. So if I want to distribute 7x through the binomial 3x minus 4, my first term will be 21x to the second power, and then 7 times negative 4 is minus 28, and this x right there has no x to combine with, so it just stays 28x. Have two terms, they're different powers, so we keep it there. Okay, the second expression that we're going to multiply is we're going to distribute negative 3x through the binomial negative 5x squared plus 4. If I multiply negative 3 and negative 5, I get 15x to the third power, because that's x to the first and this is x to the second. And when I'm distributing or multiplying, I add exponents as long as they're on the same variable, in this case x. And then negative 3x to the first times 4 is minus 12x to the first, or just minus 12x. Two terms, again, can't be combined, so that is our simplified expression. Okay, so the first half of 8.2 is multiplying polynomials, this distribution, combining like terms if we can. And then the second half is talking about factoring. And factoring is really just undoing distribution. It's writing. Your answer is going to look like a distribution problem today. So you will be given the final polynomial. We'll be given something like this, and we want to turn it into something like that. Is the idea with factoring. Okay. When comparing two or more terms or factors, it is important to find the GCF. Okay. So 3 words there. First of all, the word factor just means that it multiplies. It multiplies into that number. Okay. Common, meaning it works for all numbers involved, and greatest, meaning it's the largest possible common factor. Okay. So, for instance, a common factor of both 24 and 20 is 2, because I can do 2 times 12 and I can do 2 times 10 to get those numbers individually. So 2 is a common factor, but it is not the greatest common factor. There is a number that's larger than 2 that multiplies into both 20 and 24, and that's the number 4. Because I can write 24 as 4 times 6, and I can write 20 as 4 times 5. Okay, so when it comes to what is the GCF of those two numbers, the GCF, or the greatest common factor, is 4. How about for 16 and 10? Well, 4 goes into 16, but 4 doesn't go into 10. 5 goes into 10, but 5 doesn't go into 16. So we got to think a little smaller, and that, in this case, the greatest common factor, the largest number that goes into both 16 and 10, is just 2. Okay, so each of those were 2 numbers. If we have 3 numbers, the idea is the exact same. Okay, I just want a number that goes into all 3 of these. And I'll bring this up a couple times in the video, but let's say you recognize that 30, 45, and 60 all can be divided by 5. Okay, so 5, if I divided by each of these, 5 times 6, this is 5 times 9, and this is 5 times 12. Okay, now you might say, well, 5 is a common factor, maybe it's the GCF. But what we can see is that 6, 9, and 12 all have a GCF, or they have a common factor as well, right? 6 could be written 3 times 2, 9 could be written 3 times 3, and 12 could be written as 3 times 4. So what that means for us is our GCF isn't actually 5. We found the common factor 5, but then after that, we found another common factor of 3. So in this case, the greatest common factor for those three numbers, 30, 45, and 60, is 15, because I can multiply these together 15 times 2, 15 times 3, and 15 times 4. Okay. Now, you do not have to break numbers down like this. If you saw 30, 45, and 60 and you said, I know 15 goes into all three of them, that's awesome. I am just trying to illustrate the fact that if you start with a number like 5 that you know goes in, then just go ahead and take a peek at what the remaining numbers are. And if they have something in common, that means you haven't found the GCF. You'll know you found the GCF when these three values have nothing in common. Okay, so we'll practice that a little bit more. But overall, the GCF of these three numbers, the greatest common factor, is 15. Okay, so go ahead, pause the video if you would, and I want you to see if you can find the greatest common factor for each of these, either 2 or 3 numbers. All right, 16 and 32. This is actually a tricky one right out of the gate, right? 4 goes into both, 8 goes into both, but actually the greatest common factor of these is 16 itself, because I could write this as 16 times 1, and I could write 32 as 16 times 2. So the GCF is 16. Okay. 15 and 25. I know 5 goes into both. This is 5 times 3, and this is 5 times 5. 3 and 5 have nothing in common, so the GCF is indeed 5 here. Okay. 4 and 14. They're both even numbers, so I know 2 works for sure. 4 doesn't go into 14. It goes 4, 8, 12, and then jumps to 16. And so I can't have a GCF that's bigger than a number in the list. So 4 is the biggest that the GCF could be. And in this case, that doesn't work, but 2 does. So 2 is the GCF there. 9, 18, and 21. Well, 9 goes into 18, but 9 doesn't go into 21. So then 3 is what ends up being the greatest common factor. 9 doesn't have many factors. It's just 9 and 1 or 3 and 3. And 3 does work for all of them. And you might be asking yourself, well, what happens if I can't find a number that goes into every number or if I can't find a common factor? And in that case, kind of like this, 3, 5, and 7, these are all what we call prime numbers, meaning that the only factors are the number itself and 1. So here I would say the GCF is 1. So if numbers have nothing in common, you don't want to say the GCF is 0. You would just want to say the GCF is 1, because every number can be written as 1 times itself. And then finally here, 12, 18, and 30. Through some trial and error, you might try 2 works for all 3. So does 3. But the greatest common factor for these 3 numbers is 6. Okay. So that's GCF with just numbers. What we're going to see is what happens if I have a GCF with variables. And the first example, I'm going to write out a little the long way. And then after that, I'm shorten it up. So just bear with me on this first one. If you think about 5x squared, the 5 I could write as 5 times 1, and the x squared I could write as x times x. 15x to the 5th I could write as 5 times 3 for the 15, and then x times x times x times x times x. Okay, so the question is, what do they have in common? Well, I see 5 in both of them, and then they both have a series of x's. And so basically what we're going to do is we're going to say, how many x's do they have in common? Well, there's at least one x in both of those terms, and there is another x in both of those terms, but that's it. I can't have the first term only has 2 x's, and so I can't do anything with these as far as the GCF. So the greatest common factor for these 2 terms is 5 and then x to the 2nd power, because they each had 2 x's in them. They don't both have 3 x's, so that's why my GCF has to stop at 5x squared. Okay, that's one explanation of it. That wasn't the best. And so maybe not your favorite way to think about it, but I'll use some different language as we go through this. Okay. Another way to think about this is 18x to the fourth and 27x. First of all, what number do 18 and 27 have in common? Well, they both can be divided by 3, or 3 multiplies into both. But 9 is the greatest common factor. If this has 4 x's to give away and this has 1 x to give away, how many times can I take an x from both terms? And the answer is I can only do that one time, because 27 only has a single x. So this would be our GCF then, 9x to the first. Okay. And then here I've got a series of things going on, but again, I want you to just think about the numbers and the variables separately. So 9, 12, and 15, 12, 9, and 15, those all have a GCF of 3. That's the greatest common factor. And then I have x to the 8th, x to the 7th, and x to the 10th. And so really what this boils down to is if they all have the same variable, which term has the least number of x's, or the smallest power of that variable. In this case, it's x to the 7th. So 3x to the 7th power is going to be my greatest common factor. I can't do 3x to the 8th because there's only 7 x's in that middle term. But I do want this value to be as large as it can be. So that's why I don't do like 3x to the 6th. Okay, so that's the idea with GCFs, or greatest common factors. Okay, go ahead and pause it real quick, see if you can find the GCF of each of these 2 or 3 terms using variables as well. All right, so 5x to the 4th and 7x to the 7th. 5 and 7 have no common factor, so we'll just say 1. And then I have x to the 4 and x to the 7. So again, we're going to use the smaller of those two values. So 1x to the 4th is going to be my GCF. Again, you're thinking about this in kind of 2 different phases. What's the biggest number that can divide both? And then what's the smallest power of that common variable? Okay, 10x to the 4th and 30x to the 5th. 10 and 30 can both be divided by 10, and that's the greatest common factor. And then I have 4 x's that I can take from both terms. So 10x to the 4th would be my GCF there. Here, 16x to the 8th and 24x to the 9th. 16 and 24 can both be divided by 2, by 4, and by 8. So I'm going to use 8 as my GCF. Then I have x to the 8th and x to the 9th, so we're going to use that smaller power of x to the 8th power. And finally, I have 3 terms here. 14, the coefficients 14, 7, and 28 can all be divided by 7. X to the 3rd, x to the 8th, x to the 4th. They do have x in common, but only 3 that can be taken from all 3 terms. So 7x to the 3rd power is our GCF. Okay. So that's finding the GCF. The last thing we're going to talk about is how do you actually factor? And again, we are writing a distribution problem to which we already have the answer. Okay. So if I look at something like this, 3x minus 15, what do those 2 terms, and you can think of it as this splits the 2 terms, what do those 2 terms have in common? Well, 3 and 15 can both be divided by 3. They don't have x in common, so the greatest common factor is just 3. That's it. So what I'm going to do now to actually factor this thing is I'm going to take whatever the GCF is, and that becomes what's in front of my distribution problem. Okay, so 3 times what when I distribute, if I were to distribute this 3, okay, I want to figure out what would have to be in the parentheses so that this is what I get for an answer. So 3 times what would give me 3x? It would just be x. And then 3 times what would give me negative 15? That will have to be negative 5 or minus 5. Okay, another way to think about this is like division. 3x divided by 3. Well, 3 divided by 3 is 1. And then the x, we didn't mess with at all. Okay, and then 15, and then 15 divided by 3 is 5. So that's where we get our answer. So this is the GCF, but if you are asked to factor something, this is what we are looking for. We want you to write a distribution problem. Okay, so here, what's our greatest common factor? Well, 5 and 10 can both be divided by 5, and then they both have a single x that they can give away. Okay, so 5x, oh boy, it's a weird 5. So 5x is my GCF out front. If I take this and divide by that, okay, 5 divided by 5 is 1. This 1 is not necessary. It had two x's, and I took one of them out as part of the GCF, so now I'm down to just a single x. And again, when I multiply these, I should get 5x to the second, and I do. And then we have 5x times what will give me 10x, and all I need there is a 2. Okay, so 5x times parentheses 1x plus 2, or again, you can write it without the 1 there. Okay, this is what we're looking for factoring. And finally, 12x to the third minus 6x to the second. Well, 12 and 6 have a 6 in common, and they both have two x's that they could give out. Okay, so then my distribution problem is going to be 6x squared times what? Gives me my original back. 12 divided by 6 is 2, and there's one x remaining. Negative 6 divided by 6 is negative 1. There were two x's. I took both out as part of the GCF, so there are no x's remaining here. So it's just 2x minus 1. Okay, and this is our factored version of that. You might say to yourself, we just had a video all about multiplying. Why would we factor? And we'll get to reasons why we factor later on in chapter 8. Okay. Yep. The final thing I want to just talk about is if the first term is negative, you want to include that negative sign when you are writing the GCF. Okay. So for instance here, negative 14x to the third and positive 21x. Well, 7 divides both 14 and 21. But because the first number is negative, I want to include the negative with the 7. And again, I'll give a better justification as to why we want to do that later on in chapter 8, but you'll appreciate it if you'll thank yourself later if you take out the negative sign with it. Now, I did mess up because negative 7 is not the only thing that these two terms have in common. They also both have x to the first power that can be taken out. Okay, so then finally here, negative 14 divided by negative 7 is 2. X to the third reduces down to x to the second. And 21, be careful here, 21 divided by negative 7 is going to be negative 3. And there's no x's remaining because I took it out as part of the GCF. So here is our final expression. And the last one, negative 18, x to the fourth, and 9, x to the third. 9 divides both of the coefficients, but I'm going to take out negative 9 because I see that negative sign in front of the 18. And again, I put that parentheses a little too early because they do both have x, and they actually can both of those terms have x to the third to give away. If I divide by negative 9 and take 3 x's away, I should end up with 2x minus 1. Okay, and again, you can distribute to check your work very easily to see, did I do this correctly? Okay, and encourage you to show your work, but I don't want to take your time by showing you work here. All right, what is the greatest common factor and how can I use it to factor polynomials? So we want to find the largest number that divides all the coefficients. We want to find the largest number I'm just going to use x in this. Find the largest number of x that can be taken from each term. And then we're going to write as a distribution problem. And that'll wrap up part 2 of 8.2. Sorry, it's a little longer video, but hopefully it made sense.